Yes, it's on.
Okay. All right. Yeah. So welcome to workshop day 2. Today's be multiplication and square speed tricks. So basically, last workshop, if you guys were here, was more of an introduction to what math UIL is and how it's going to function in school this year. But this workshop is going to be diving into our first actual math concept that's pretty commonly tested on the math UIL tests. And so, yeah, so basically we'll just have different tricks pertaining to multiplication and squares. So if you guys have any questions, you can just mute for now, and then once you have a question, then just unmute. But yeah, like I said before, if you have any questions, then feel free to ask at any time. Okay. Oh yeah, and make sure you guys are watching my stream. Okay, so for today's workshop, first it'll just be going over our first step, our first set of tricks, which is how to multiply by 25, 50, 75, and 125, all within seconds in your head. And then going on to times 11, 101, 1001, inverses, how to square any number ending in 5, how to square any two-digit number, and then also our last topic, problem-solving squares. And then once we go over all the topics, we'll end it off with the Kahoot for review. Okay, so if you guys were here last time, this is what we went over, sort of how, just a basic trick we went over last time just to show you guys how we would teach and just get used to our teaching style. But yeah, so multiplying by 25, just for a refresher, you want to first just, whenever you see this problem, you want to first, whatever number you have, so a in this case, you want to first divide by 4 and then just multiply by 100. And then, for example, if you have 52 times 25, you just want to divide 52 by 4 to get 13 and then times 100. And that. Okay, I think Hannah will do this one.
Wait, sorry. I think my screen froze. Which slide are you on?
Oh, just the times 25 one.
Okay.
Okay, come here. So if 52 times 24, 25.
One method you can use to multiply by 25, you're going to divide the number by 4, and then you're going to look at the remainder. If the remainder is 1, then the last two digits will be 25. If the remainder is 2, then the last two digits will be 50. If the remainder is 3, then the last two digits will be 75. No remainder, then the last two will just be zeros.
Did you hear?
In the example 67 times 25, 67 divided by 4 is 16 with a remainder of 3. And if you look back, if there's a remainder of 3, the last two digits will be 75. So you can smush them together, and the answer will be 1675. So here we have some example problems. You can try to solve them and type in the answer to the math general discussion. And so the first one is 37 times 25.
As a trick, 52 times 25. You divide it divided by 4 and times 100. So it's 1,300. 52 times 25. What is the trick? Yeah. The trick is you don't have the time. You just divide, 52 divided by 4 and times 100. You'll just see. Math. I don't know 37 divided by 4. I thought you were sitting there listening to the We're trying to have a conversation with Teddy's lesson.
Okay, so Sergio and Master 12345, you guys are both correct. 37 times 25 is 925.
Okay, but 50. That's a trick, okay? When you see times 50 problem,
Okay, yeah, so whenever you see a times 50 problem, it's similar to times 25, but instead of dividing the number by 4, or yeah, dividing the number by 4, you would just need to divide it by 2, since 50 is twice of 25. But then the last step is still the same, you just multiply by 100. And so explanation, so multiplying by 50 is like multiplying, rewriting it in a different way. And so looking, yeah, and so looking at the model, if you have a number a times 55, then just divide a by 2 and then so for example, if you have 48 times 50, you want to first divide by 2
divided 48.
to get 24, and then just multiply 24 times 100 to get 2400 answer. Now you guys can try these problems in the
You can't. Okay. Just divided 36. Yeah.
That's 1800.
Yes.
Two two zero zero.
No. 54 divided by 2等于多少？
Sorry. 2700.
That's right.
This one's easier because it's divided by 2.
Okay. No,
Can I
no, no.
type it down?
No, it's alive. You can't.
yeah, so the first one is 1800, just divide by 2 times 100, and then same thing with the second one, it's 2700. So yeah, good job.
So there's another way to multiply by 50. So it's basically the same way as Lush explained it, except you don't have to deal with decimals. So you divide the number by 2, but instead of dividing with fractions or decimals, you get a remainder. So you divide the number by 2, and then then you add 2 zeros if the remainder is 0 at the end. So let's just say you have what 14
Here,
times
yeah,
50. So 14 times 50, you divide it by 2, so it'd be 7 remainder 0, and then you add 2 zeros to that, so that would be 700. Or the other way it could turn out is it would have a remainder of 1. So let's have the number 17. So divide 17 by 2, and then you get 8 remainder 1. So then you add a 50 to the end of it, so it would be 850. Also note that this method also works with 5s, except it would end in a 0, just a single 0, and then if the remainder is 1, it would end in just a 5, or any multiple well, how should I put it? It's 5 times any what? I'm sorry, I'm losing my words. So it would work with numbers like 500, 5000. It's just you add one more 0, if that makes sense. But let's just say you have 50, it's 2 zeros. 500, it's 3. 5000, so on and so forth.
8450.
So
yes, so with this example, if you have 69 times 50, you would just divide by 2. Since it's an odd number, you just automatically know that it will always have a remainder of 1. And so since it's odd, just add a 50 to the end.
okay, so try these.
2250. 75000. 是不是啊？
I don't know. You're doing it really fast.
Yeah, so yeah, the first one just divide by 2 since it's odd, add a 50 to the end, and then
teacher.
you add 2 zeros to the end.
Divided number by 4, then multiply by 3. Then last multiply
Okay. So when you're multiplying by 75, you're going to divide the number by 4, and then you're going to multiply by 3, and then lastly multiply by 100. Because in the 25 trick where you divide by 4 then multiply 25, it's kind of like that, except since 75 is triple 25, you're also going to multiply by 3. So in the example here, 28 times 75, you're going to first divide by 4, so it equals 7. Then you're going to multiply by 3, so it's 21, and then you're going to multiply by 100, giving you the answer 2,100. So it's basically the 25 trick with multiplying 3 too. So here are some examples. The first one is 64 times 75.
Do you know this one? Oh, try. 6 divided by 4 times 3.
12000.
Here, is it okay if you mute yourself right now?
除以4等于10。14乘以3等于。
Okay, so
Okay, so Sergio and Massa, you're both correct. 64 times 75 is 4,800, and then 160 times 75 is 12,000.
okay, so multiplying by 125. So with this one, you're always going to first divide the number by 4, but then once you divide it by 4, whatever number you get from that, you want to add it back to the original number. So looking at the model, you first want to do, or if you have a number a times 125, first divide a by 4, and then whatever you get from there, add it back to the original a value. And then once you add that back, just multiply by 100, and then you should get your final answer. So for example, if you have 32 times 125, first you just want to divide by 4 to get 8, back to the original number, so in this case 32, get 40, and then just multiply 100 to get 4,000. So go ahead and try problems in the chat. Joss and Deva, do you think you can mute yourself right now while we're just like teaching, and then if you have questions, then you can. Thank you. Okay, so yeah, these were 3,000 and 11,000. So yeah, you guys got it.
So, when you multiply by 11, so if you're multiplying a two-digit number by 11, you take the rightmost digit of the number you're multiplying by 11, and you write it down. Then you add the two digits. So, let's say, can we go to the example?
Yes.
Okay, so you have 34 times 11. So you add 3 and 4. So, you get 7, and then you write that down. You may get a number over 10, and that's fine. You just carry the tens place over, and then you write down the number in the tens place of the number you're multiplying, and then you add it onto whatever you carried over. So if you had let's say the number 75, so you write down a 5 because 5 is the rightmost digit. Then you add 7 and 5, you get 12. So you write down a 2, and then you carry over a 1. And then you do 7 times 1, which is 7, but you carried over a 1, so you have to add that. So then it's an 8, so it would be 825.
Yeah. Yes, so go ahead and try these. For the second one, just remember the carryover trick. So yeah, the first one is 165. So yeah, you guys got it. And then the last one is 517. Yeah.
Okay, so when you're multiplying by 101, it's pretty easy. You just write the original number twice. Because if you're multiplying it, you're just left with the same number twice right next to each other, as you can see, like AB, AB. So, for example, if you were doing like 39 times 101, it's just 3939. Or if you're doing 45 times 101, it's just 4545. So here it's an example. It's just 89 times 101. And yep, the answer is just 8989.
So multiplying by 1,001, it's sort of similar, but so there's two instances with multiplying by 1,001. One you can have 2-digit and the other 3-digit. So whenever you have a 2-digit times 1,001, all you have to do is just like the 101 just rewrite the number twice, but if it's 2-digit, make sure to add a 0 in between. But when it's 3-digit times 1,001, then you just rewrite the number twice. So for example, if you look at the model, if you were to like multiply it all out, then you would get, so like looking at a 2-digit times 1,001, if you were to multiply it all out, then you would be left with AB, the number, a 0 in between, and then the same number again, AB. So like some examples, so if you have 24 times 1,001, then just write down the number itself, so 24, and then write the number again, but just make sure to add a 0 in between. So 24024. But then if it's 3 digits, then all you have to do is write it down twice. So 134, 134. That's it. So yeah, go ahead and try these problems in the chat. Yeah, so yeah, just add a 0 in between, 56056, and then for the second one, just rewrite it twice. Yeah, good job. All right.
Multiplicative and additive inverses are just fancy terms for things that you should already know. Multiplicative inverses are basically reciprocals, so you just take a fraction and flip it. If you had 4/7, you'd have, if you take the reciprocal, also known as the multiplicative inverse, you'd get 7/4. If you had the reciprocal of the number 4, it would be 1/4. Additive inverses are also known as the opposite of a number. So, can we, like,
Sorry,
sorry,
what?
can we, like, bring up the additive inverse information on the right,
Oh
or
yeah,
is my
it's
screen? Is it
yeah, I
there?
think it's green, yeah.
Yeah, I think my screen's not updating. That's fun. Okay. I'm gonna keep explaining. So additive inverses are also known as the opposite, where you take a number and then you multiply it by -1. So 5 times -1 is -5. -16 times -1 is 16. 0 times -1 is 0, and so on. So the screen's still updating for me, so can you like tell? Okay, it updated. So squares memorization. So what I would personally recommend is if you can add really, really, really fast, then you don't exactly have to memorize squares because then you can add odd numbers. So a cool trick with squares is squares are the sum of odd numbers. So 1 squared is of course 1. 2 squared is 4, which is 1 plus 3. 3 squared is 9, which is 1 plus 3 plus 4. Oh, no, not 4. I can't talk. 1 plus 3 plus 5. 4 squared is 16, which is 1 plus 3 plus 5 plus 7, and so on. If you can multiply really fast, you should still have, what? 1 through 9 squared memorized, but, I mean 1 through 10, but if you can multiply really fast, you shouldn't really have problem with doing, 11 squared through infinity, if you can multiply fast. But if you don't think you're that fast, especially you people because you are relatively new here, then I do recommend memorizing squares up till 30 squared. Yeah. So, cube memorization. So, again, if you can multiply fast, you're good. But I'd actually recommend memorizing cubes a bit more because it's a bit more work. You have to get the square and then you have to multiply it by whatever number you're cubing. So let's just say you have 4, right? So 4 squared times 4 is 4 cubed. It takes a bit, but if you can do it fast enough, you should be fine. But again, since y'all are beginners, try memorizing them. So yeah. Next slide.
Okay, so if you're squaring a number in 5, the last two digits will be easy because they'll be 25. But for the first digits, like the first two here, you have to multiply the 10 digit by the 10 digit plus 1. So if you're looking at 55 squared, the last digits will be 25. So that part's easy. but the first digits will be the tens digit, which is 5, and then the tens digit plus 1, which is 6. So 5 times 6 is 30, and then you just kind of smush them together to get 30, 25. So here are some examples: 75 squared and 105 squared. Okay, so Sergio, you're close for the second one, but since 10 digit plus 1, it's going to actually be 10 plus 1, so it'll be 10 times 11. So it won't be 1025, but yes, Master, you got it right. It will be 11,025 because you're doing 10 times 11.
So scoring any two-digit number. So this one's a bit, it's very lengthy. It has a lot of steps to it. But if you guys can memorize these and just sort of get used to it, get practice, then this should be pretty easy too. So for this one, this basically works with any two-digit number whenever you need a square. So what you first want to do is whatever two-digit number you have, so like let's say for example you have AB squared. What you want to do is sort of keep them separate right now, like keep in your mind, keep it separated, and just do A squared and B squared. So take the number A square individually from B. And then keep that number in mind. So basically, let's say you have 52 squared. So what you want to do is first square the numbers individually. So you have 5 squared and 2 squared. So 5 squared is 25, and then 4 squared, or 2 squared is just 4. But whenever you have an answer that's a single digit, you want to add a 0 behind it. So for example, this one's 4, just make sure to have a 0 behind it. So your two numbers are 25 and 04. Once you have those two numbers, just smush them together. So then your number will be 2504. But that's not all you have to do. This is one part of the answer. Next, to get the second part of the answer, you want to take the numbers a and b, so not the squared, but just the original a and b values, and multiply them together. So with 52, you have 5 and 2, and so multiply 5 and 2 together to get 10. And then you want to just double it, so 5 and 2 times 2, or let me get my pointer. So you have 5 and 2, that's 10, double it, that's 20, and then once you double it, you just multiply by 10, and then that's 200. So yeah, so you had 5 and 2 to get 10, times 2 is 20, times 10 is 100. So now that you have these two numbers, you can just add them together and get 2704. So yeah, this one is a bit, it has a lot of steps to it, and you're going to need to do a lot in your head, but it should work out eventually, especially for the smaller numbers. It's pretty easy. So yeah, go ahead and try these, and it's okay if they take a while. You can also probably use paper on these since they require a lot of steps. And let me know if if you guys want me to like go back to the steps since there was a lot. Okay, yeah, I'll go back. Yeah, so just try to use 52 as the example, and then here, so it's 53 squared and 76 squared. I'll put it in the chat. Put it in the chat, and just for reference, the caret key or the caret like symbol like right next to the 53 is just for squaring.
So, is it okay if I talk about a different method to do the same thing?
Yeah, you can talk about it, but I'm gonna have to go soon, so you can do that right after this slideshow ends, and then you can just share your screen.
Alright, yeah, that's cool.
Okay. All right. I'm gonna just go ahead and go over these really quick. So 53 squared is 28 and 9. So yeah, you guys got that. And 76. So yeah. So it's pretty easy to do that trick with smaller numbers like these. But whenever you have both of them that are like above 5, then it gets a bit tricky to add them because yeah. Yeah, it's fine if you couldn't get number 2. I just had to go over it a bit quickly. But yeah, for number 2, if you just do the same steps again, you should be able to get it.
Oh, sorry. So, problem solving powers. So there's a lot of questions on these tests which ask you to put a number to the power of a very high number, and they ask you for the last digit of that number. It usually seems really daunting and difficult at first because like you don't really have the time to do 3 times 3 8 times. But there is a trick. This trick is that every time you put a number to a higher power, it's eventually repeats. For example, we have 3's here. So 3 to the power of 1, its last digit is 3. 3 to the power of 2, its last digit is 9. 3 to the power of 3, its last digit is 7. 3 to the power of 4, its last digit is 1. And then at 3 to the power of 5, it repeats again at 3, and it goes 9, 7, 1. So it's going to keep doing that forever. So what you can do is you look at the exponent and see, okay, so it repeats every 4 numbers, right? So then, wait, sorry, it was every 5, right? Um,
Every 4, right?
it's every 4. Yeah, sorry. Ah, I had an explanation. Sorry. My brain just like slightly died. Okay. So, you divide the number by the amount of times it repeats, so it's not the amount of times, the interval that it repeats. So in 3's it's 4, so you divide 8 by 4, and then you have a remainder of 0. Be sure to keep track of that remainder. With that remainder, you put 3 to the power of that remainder, and then you take the last digit of that. So sorry. So you divide 8 by 4, and then you get 2 remainder 0. So 3 to the... wait, no, is that right? I don't think that's right. Sorry. I think my explanation's off. Is it? Sorry. Ah. So basically, squares repeat. So, and then look at the pattern. And based off of that pattern, you can basically get the last digit of every exponent. Yeah.
Here, so
Yeah,
for
sorry.
okay, yeah. So for example, you guys don't have to do this one because it's different patterns for every power. So for example, the power of 8, it is you have 8, 4, 2, 6, 8, 4, 2, 6, and it'll keep repeating that every time. It repeats every 4, that sequence. So 8, 4, 2, 6 repeats every 4. So since since it wants us to do 78, you want to just divide 78, whatever the square is, just divide 78 by however many times it repeats. So since it repeats every 4, and that's usually for all powers, just divide 78 by 4 to get 19 remainder 2. And then so because you have a remainder of 2, you want to look at the number that's corresponding to these. So 1, 2, 3, 4, 5, 6. So because the remainder is 2, you want to look at the 2 over here and find the answer to be 4. And so usually on a number sense test, you won't get this chart, but I believe on Math UIL and like paper and just like in general in school, if you guys ever come across this, then you'll usually get the chart. So how do you find the answer from the remainder? So whatever your remainder is here, so looking at it's 2, you want to refer back to the chart and whatever the number, so you want to just find whatever 2 matches with. So since 2 matches with 4 in this case, the answer is 4. So yeah, just refer back to the chart. Okay, yeah. So that was the last topic for this one. And so we have an optional worksheet. We'll put it in the chat like once this workshop's done, and it's optional. You guys don't have to do it. It's just to get a better understanding of today's topics. And then yeah, now we'll play the Kahoot. So I think you guys should. I'm gonna probably have to go now. So you guys should. Hannah can share the Kahoot, and then if there's time, Ramesh, then you can show the second method.
All right.
Hold on, I'm gonna share my screen now.
Okay, yeah.
Okay. Okay. Wait, Ramesh, can you see it?
Yeah, I can see it. So we need one more person to join, right?
Yeah. I'll wait like 2 more minutes.
Yeah.
Okay, I think I'm just gonna start it then.
Yeah. Okay.
Mhm.
Did we cover this one?
I don't think so. So I guess on this one, just try your best.
So, here's a slight explanation from what I see here. So square roots of 14, you kind of have to estimate that, and then square root of 100, which you should know, which is 10, and square root of 14. So you have to estimate where the square root of 14 falls. So 3 squared is 9, 4 squared is 16, so it's somewhere in between. So it's safe to assume that it's 16 or above. So then you have 10. So it has to be in between 10 and what? Has to be in between 10 and 9 because, well, no. Sorry, I messed up. So it has to be, wait, sorry, again, my brain keeps dying. Okay, it has to be in between 10 and 3, right? Yeah, no, right? Can you confirm? Wait, sorry, it's better if I visually explain it. Is it okay if I screen share?
Wait, hold on. There's like one more question, so
Yeah,
I'm gonna
I'm just gonna screenshot this and then I'll explain it later. Okay, you can go ahead. Yeah. Okay, so I'm going to share my screen. Hopefully it works. Okay. So we had the product of the two largest perfect squares between the square root of 14 and the square root of 100. So memorizing your squares, you should know what the square root of 100 is. You can type that in actually no, you don't even have to type it in. It's 10. You should know that. Okay, so you have 10. And then you have square root of 14. Square root of 14 isn't a perfect square, so therefore it's going to be an irrational number. So you have to kind of approximate where it is. So how you do that is you take the nearest perfect squares to 14. So 3 squared is 9, so you have 9, right? And then 4 squared is 16. 9 is less than 14, 16 is greater than 14. Right? So 14 squared, the square root of 14 kind of falls in between these two. Okay? So now you know that the square root of 14 is greater than 9. But it's also less than, what? That is a weird question, actually. It's less than 16, but it's greater than 9. Okay, then it has to be in between. This is 2 squares. Okay, sorry. It has to be in between the square root of 14 and 10. But there
wait.
are
Hold
no.
on.
Wait, I don't think that. Yeah?
Maybe we should just explain the square root one easier, because it's kind of okay.
Yeah.
So let's explain that one first.
Okay.
So like when it's asking for 53 squared or 76 squared, I don't know about you guys, but that way they taught, it's kind of complicated. So in the general chat, I'm going to show you a different formula. I'll type it in right now, but so basically the formula is a squared plus 2ab plus b squared. So I'll just use the number 53. So what you want to do is split the number 53 into two easy numbers. So I'm going to split it into 50 and 3.
So
Basically 50 is a, b is 3. So all you have to do is plug it into this equation a squared plus 2ab plus b squared, and it'll give you the same answer. So if you just memorize a squared plus 2ab plus b squared, and you remember to split the number into two easy parts, then you can just use this formula. So a squared 50 squared is 2500 plus 2ab, which is 300, and then b squared, which is 9. You just add them together, which I believe is 2809. Yeah. So I don't know about you guys, but I feel like if that was too many steps for you, then you can just memorize this formula a squared plus 2ab plus b squared and just split the number into a and b. And then I feel like that might be quicker for some people.
So adding on to what Hannah said, so how you actually get that formula is a plus b all squared is equal to what she said. So I typed that in the chat. So a plus b in parentheses squared is equal to that. So where she got splitting 50 plus 3 is 53 is so in the tens place it's 5, so 5 times 10, 50, and then you have 3, so you split it that way, and then you plug it into the formula as she said. And should I re-explain the problem solving powers thing, because I don't think I did really well on that.
I think it was okay.
Just to ask the people who were attending, did you get it, or should I re-explain?
If you guys are good, then you guys can leave now, because I believe it ends at 5, so...
Yeah. Okay.
If you guys are good, then we'll see you next time, I guess.
Alright then. Yeah, bye.
So bye, guys.